Hi everyone, good morning to all. Welcome back to Google Classroom. In this session, we are going to discuss a new chapter, that is chapter 10, Circles. In this chapter, first section, it is given that the definitions of some terms related with circles. First of all, the definition of a circle. A circle is a collection of all points which are at a constant distance from a fixed point. Okay, here the constant distance is the radius and that fixed point is the center. So, the circle is a collection of all the points which are at a constant distance from a fixed point. Then the various terms related to a circle like chord, segment, sector, etc. you already studied in the lower classes. If this is a circle with center O, then this is the center and OA. This is the line segment joining the center to the point on the circle. This is the radius of the circle. So OA is the radius. Okay. Radius means center to any point on the circle. Then diameter means the line segment joining any two points through the center. Line segment joining any two points through the center. That should be passes through the center O. So here BD is the diameter. So BD is the diameter. Okay. Next, the line segment joining any two points on the circle, that is called chord. Line segment joining any two points on the circle is called chord. So here CE is the chord. Okay, O is the center. O is the center, OA is the radius, BD is the diameter, C is the chord and O is the center. One more thing is the longest chord of the circle is the diameter. Longest chord is the diameter. Okay. The next is sector and segment. So here this is a circle with center O. Then segment means the area enclosed by the chord and an arc. Arc means part of a circle. Okay. So this part is known as segment. This is the segment. Area enclosed by the chord and an arc. Okay, but sector means area enclosed by two radii and an arc. Two radii and an arc. So this is the sector. This is the radii means plural form of the radius. Okay. So two radii and arc, that area enclosed is known as sector. The area enclosed by chord and an arc is known as segment. Okay. The next is, if this is a circle with center O and there is a line AB outside of the circle. That means there is no intersecting point or common point between this line and this circle. Then it is known as non-intersecting line. Non-intersecting line. In this case, AB is non-intersecting line. Okay. Next case, if there is two common points for a line and a circle, then this line AB is known as secant. AB is the secant here. Okay, secant. Two common points. So, this is AB is known as secant. The next is, if there is only one common point between a line and a circle, then this line is known as tangent. Tangent. If there is no common point between line and circle, means it is known as non-intersecting line. Then if there is two common points, then it is known as secant. Then if there is only one common point for a circle and a line, then it is known as tangent. That line is known as tangent. Okay. So the tangent to a circle is a line that intersects the circle at only one point. That means there is only one common point for a circle and the line. So that line is known as tangent to a circle. Tangent to the circle. At a point, there is only one tangent for a circle. At a point, there is one and only one tangent for the circle. Okay. But there are many tangents for a circle because there is infinitely many points on the circle. Then the tangent to a circle is a special case of the secant when the two endpoints of its corresponding chord coincide. When the two endpoints of its corresponding chord coincide, then it is a tangent. Okay. This common point of the tangent and the circle is known as point of contact. So this is the point of contact. Point of contact. Okay. The common point of the tangent and the circle is called point of contact. Here this is the point of contact. There are two important theorems in this chapter. One of them is theorem 1. A tangent to a circle is perpendicular to the radius through the point of contact. A tangent to a circle is perpendicular to the radius through the point of contact. So, we can draw the required figure. Circle with the center O. AB is the tangent. P is the point of contact. O is the center. Then R is the point on the circle of the line segment OQ. So according to the statement, it is given that a circle with center O and a tangent AB at a point P. And we have to prove OP perpendicular AB. OP perpendicular AB. To prove this, we have to do one additional construction. For that additional construction, we can take a point Q other than P on the tangent, join OQ. Suppose OQ meets the circle at the point R. That means R is the point on the line segment OQ. Okay. So when we consider the circle with center O and the tangent AB, then we already know that among all the segments joining the point O to a point on AB, the shortest one is the perpendicular to AB. The shortest distance or shortest line segment from the point O to the point on AB is the shortest when that is perpendicular to AB. So to prove that OP perpendicular AB, it is sufficient to prove that OP is the shortest distance than any other segment joining O to any point on this AB. Okay. So here we have to show that OP is the shortest distance than any other line segment joining to O to any other point on this line segment AB. For that, we select this Q. Okay, other than P. Point on the line AB other than P as Q. So here we have to show that this OP is the shortest distance than OQ and all other points. Then we can say that OP is the shortest distance. Same way OP is the perpendicular to AB. Okay. For that OP equal OR because why OP and OR is equal because the two are radius of the same circle. So radius of the same circle are equal. So OP and OR are equal because radii of same circle. Okay. Then next we can take OQ. We have to find OQ. We have to show OQ as greater than OP. Okay. So what is OQ? OQ means OR plus RQ. OR plus RQ. So clearly we can identify that this OP is smaller than OQ or OQ is greater than OP because this OR is already the plus 1 value. That means this OQ should be greater than OP. Okay. Or we can say that this OQ is greater than OR. So OQ is greater than OP2. So here we can write, so OQ is greater than OR because OQ is OR plus 1 value. So OQ should be greater than OR. So same way we can write OQ is greater than OP2 because OR and OP are same, equal. So we can substitute this OR as OP. So we got OQ is greater than OP. So we can write it as another word, that is OP less than OQ. OP less than OQ. Thus OP is the shortest distance than any other segment joining O to any point of AB. So when we join this to any other point, then we will get this O. If it is S, then OS plus ST. That means OS and OP are equal. So we know that OP is shorter than OT. Then any other point we can take. Anyway, OP should be the shortest distance. Okay. So here OP is the shortest distance. OP is the shortest distance between AB and O. So we can say that OP should be perpendicular to AB. OP should be perpendicular to AB. This we have to prove. So hence it is proved. Now we have to discuss exercise 10.1. Question number 1. How many tangents can a circle have? We already know that many points on a circle. So we can draw infinitely many number of tangents. Okay, for a circle infinitely many tangents, but through a point there is one and only one tangent. Clear? Now the second section, first question. A tangent to a circle intersects it in dash point. Tangent to a circle intersect it in how many points? 1 point. The next question, second sub question. A line intersecting a circle in 2 points is called a dash. 2 points means it is a secant. Now the third sub question. A circle can have dash parallel tangents at the most. That is 2. 2 tangents are parallel at the most. Okay. That means 2 parallel tangents at the most for a circle. Then the fourth sub question is the common point of a tangent to a circle and the circle is called. That is point of contact. That is point of contact. Okay. The next question is question number 3. A tangent PQ at a point P of a circle of radius 5 cm meets a line through the center O at a point Q so that OQ equal 12 centimeter, then length PQ is. 4 options are given. From there we have to find the answer. The 4 options are A 12 centimeter, B 13 centimeter, C 8.5 centimeter and D root 119 centimeter. For that we have to draw the figure first. So according to the question, this is the circle with center O. There is a tangent PQ at a point P. So this is the point of contact P. Then Q we can mark anywhere. Okay, here I mark it as Q. This is a tangent, so it is a line. So this is the point of contact P. Then the radius is given as 5 cm. So we know that OP is the radius. So it will be 5 cm. Then it is given that the length OQ. From O to Q, that length is given as 12 centimeter. Then we have to find the length PQ. This length we have to find. Then we already know that the circle's center, radius to the tangent is right angle. So this angle is right angle. This is also right angle. Okay. So from the theorem 1 we know that tangent to the radius is right angle. Now we identify this OPQ is a right angled triangle. So by the Pythagoras theorem we get OQ square equal OP square plus PQ square. Okay, then OP square is 5 square plus PQ we have to find, so PQ square itself, that is equal OQ square, that is 12 square. Then 25 plus PQ square equal 144. Then PQ square equal 144 minus 25. 144 minus 25. That is equal 119. So PQ square equal 190. So PQ equal root of 119 centimeter. So here the answer is root 119. And the option D is the correct answer. Correct option. Option D is the correct option in this question.